What is going on, guys? Hope you're doing freaking awesome. So in this video, I want to show you how to create custom layers. So far, we've seen how to build very flexible models using subclassing. Now we want to go one level deeper and even create the layers by ourselves. So I'll show you what I mean by that. But first, just to explain the code we have in front of us right now, we just have the imports that we've seen pretty much every video. And then we have these two lines to avoid any GPU errors. And then lastly, we're just loading the MNIST dataset. So this is just to save some time. And so what we're going to start with is creating our own custom model, so sort of like we did in the last video. So it's going to be very simple. We're going to do class my model. We're going to inherit from keras.model. We're going to start with defining the init method. So we're going to do self, and then we could specify the number of classes. For MNIST, that's 10. And then we're just going to call the super my model self dot init. And then we're going to do self dense 1. So all we're going to do here is just create two dense layers. All right. We're going to do layers dot dense. Let's do 64 nodes. And then self dense 2 is layers dense of num classes. We're just going to do the call. So we're going to call self and then x. So the input, or let's call it input tensor. And then we're going to do self.dense1 of input tensor. And then let's run a tf.nn.relu on top of that. So this is just what we've seen in the last video. This is why I'm going through it pretty quickly. And then we want to return self.dense2 of x. All right. So now let's quickly build just a model compile, a model fit on that. So we'll do model equals my model. We'll do model.compile. Loss equals keras losses sparse categorical cross entropy from logit equals true. And then let's do our model.fit. So you've seen all of this before, so I'm just gonna write it out pretty quickly. All right, so now we have a custom model using subclassing, and then we're just defining our compile and our fit and our evaluate. So just let's just make sure that this actually works. So if we run this, we see that it's actually training, and this should go relatively quickly because we just have, so we have a very, very small network, like 64 nodes and then 10 output nodes. Let's actually talk about what I want to show you in this video. So we now want to actually create these layers by ourselves. Right now we're using the layers from Keras, and that has the dense layers in it. And then we're using tf.nn.relu. And that's all right. And you can build very flexible models using that. That's actually, in most use cases, that's fine. But sometimes, and just for understanding, you want to actually be able to build those layers by yourself so that you really understand what's going on more under the hood. So I'm going to show you how to do that. And let's do class and let's do dense. And we're going to inherit from layers.layer. We're going to create our init function. So we're going to do init and then self unit. And then we're going to specify the input dimension. So all we got to do then is we got to run the super method. So super dense self dot init. Then we're going to do self dot w is self dot add weight. So there are actually multiple ways of doing this. This is the more easy way. You could also do initialize it by yourself with a tf.variable, but this is the easy way. I'm going to show you in this way. Now, the first thing we got to do is we got to set it to a name. Let's just call it W. And actually, this is quite important. You'll see in the next video how we can save and load models. I found out that if you don't actually specify a name, you can't save the model. So this is very important. And then we're just going to do a shape. We're going to specify shape as input dimension and then to units. All right, so input dimension is just what we have. In the beginning, it's going to be 784, which is 28 times 28. And then units is just what we're going to map it to. So when we're using layers.then64, the units is 64. Then we can also specify the initializer. So we're going to do random normal. And you could check out what other initialization methods you can do. And then we're going to specify trainable equals true. And so trainable equals true, this is for layers like batch norm and so on, where some of the parameters are not actually trainable. But so all of our parameters in this dense layer are going to be trainable. Then we're going to do self.b is self.add_weight. We're going to call it b, and then shape is just going to be units, right? So we don't have to, so we're doing the matrix multiply with w, and that's why it has to have the input dimension. But then it's just going to be unit nodes, so we're going to add one for each of them. That's why we just have units right here. Then we can do initializer, and we're just going to initialize it as zeros. And then this is also a trainable parameter. And lastly, we just have to do the call method. So call of some inputs. And we're going to return tf.matrixMultiply with the input, and then self.w. And lastly, we just got to add b. So now we can actually replace this right here. So we can do, let's do self.dense1 is dense, and then let's do 64, and then 784, and then let's do self.dense2 is dense of 10, and then 64 as input. So I'll comment that one right there, and let's see if this works. All right, so we seem to get pretty much equal results as we did on the last one, and most importantly, it actually runs. So one thing you can notice here, first of all, is that on these ones, we didn't have to specify the input dimension. And this is what we're going to call as making the layers lazy, in that you don't have to actually even say what the input dimension is. It's just going to work that out. So that's what we want to do now. We want to actually remove this part and make it work regardless of the input dimension. So how we can do that is that we're going to create a build method. All right, so we have our init right now, and we're going to remove the input dimension right here. And then we're going to do a build method. So we're going to do define build. We're going to have self, and then we're going to have an input shape. And then we're actually going to create the W's right here. So we're going to paste that in the build method instead. And now what's so great is that instead of using input dim, we can do input shape, and then we're going to do sort of the last of those. So in this case, we have the training examples on the first dimension, and then we have 784 because of the way we've reshaped it right here. So that's why we do -1 here, and then we're going to do unit. Although what we're going to do in the init method is do self.units equals units. And then we got to do replace these units right here with self.units for both of the for the W, and then self.b. So what's amazing now is that if we would run this, we wouldn't have to specify the input dimension. This hopefully will work. So we can do that num classes. So let's run this now, and let's see what we get. And it seems to work. And now we see that these two are pretty similar, right? The functionality of them are pretty much identical. And then you might be saying, well, we're still using tfnn.relu. It would be nice to actually create this ourselves as well. And so that's our next step. You can do this in two ways. You can create a function, or you can create a class like we're doing so far. I think the most common way is actually defining a function. But let's just create a class, and you can try out making a function. It's going to be pretty much the same, but we're going to do class myRelu, and then we're going to do layers.layer, and we're going to do define init of just self. We're going to call super of myRelu self and then .init. And then for our actual call, we're just gonna return tf.math.maximum of x and 0. This is just gonna return the maximum of x or 0, which is exactly the relu, right? So at this point, you might be saying, well, how would we actually create this tf math maximum function? You might be fearing that this is a way of cheating. And so what I would say is that this would be even more low level. And this is something you can try out, and you could read the documentation and the source code for how they've actually implemented this function and so on. But there will always be times where you can go even deeper and explore the details. And so this is where I would draw the line, in that we can use these mathematical operations on these tensors. So when we have this myRelu, we can do self.relu is myRelu. So we got to instantiate the class. Although if you use a function, this wouldn't be the case. So what we got to do then is we got to replace this tf_nn.relu, and then we're going to do self.relu on top of that. So we can run this first of all. So now you've seen how to build these models by yourself with Keras subclassing, and then also how to actually build these layers like dense layers and relu functions. So these are pretty simple ones, but you could imagine building more complex ones as well. And I also suggest you to try that out. All right, so that's it for this video. Thank you so much for watching, and I hope to see you in the next one.